Hi ladies, last time we talked about how to form a cation, meaning that it loses electrons, creating a positive. Now we're going to work on how to create an anion. Anions are going to be produced whenever an atom gains one or more electrons. Note that anion is typically those of the non-metallic variety, and it is not the same as the element name. So remember, as before, whenever we're naming things, let's look at potassium again. So we have potassium, which usually creates a positive one charged cation. Anytime you try and name that anion, you would simply state the name of the element that you're working with. So this one would be potassium. Another example could be calcium, which has a 2+ charge. That would simply be calcium ion. Okay, now whenever you're naming the anions, they're a little bit trickier. So the name of an anion is going to end in IDE. So you usually take off the last syllable, or the last section of the name. So let's look at chlorine, which is Cl. It usually loses one, or it gains one electrons to become negative. So chlorine is the name of the atom, and we're going to take off the ending of the word and replace it with IDE. So we go from chlorine to chloride. Oxygen is very similar, except the last portion of the name is the YGEN, so it is called oxide. You get more familiar with these as you write them, and it will be a little bit more second nature the more you practice. So this will be a chloride ion, where oxygen, which has a little bit different of a name, would be an oxide ion. So atoms that are nonmetals, so remember, if you look at our periodic table, it goes metals are over here, and these are our nonmetals on the right. Now, nonmetals and sometimes metalloids are going to form anions. Remember, anions are going to be negative. And by gaining enough valence electrons, they want to look again like that noble gas. So if you looked at fluorine and it gains one electron, it wants to look just like neon, which is its next door neighbor. Chlorine wants to look a whole lot like argon, and so on and so forth. And you can kind of see that if you draw the electron configuration. So if you look at chlorine, go ahead and give that a shot. See if you can draw that electron configuration for chlorine, the atom. And what you'll find is your valence electrons are here in the third energy level. And you have a total of 7 valence electrons, 2 plus our 5. Now, it can either lose all 7 of those valence electrons, or it can gain one more, and that sounds a whole lot easier and a lot less work. So it gains 1 electrons to create the exact same beginning of our electron configuration. However, the valence electrons are now that full octet. Remember, octet means that it has 8 valence electrons. Those are really important. So those valence electrons are going to finally fill that full octet, giving you a chloride ion. And that's CHLOIDE ion. Okay, so that gaining of that single electron is going to change the charge of your atom to become an anion. And you're also going to get this full octet. You have 2 here, plus our 6 gives you our total of 8. And if you want to compare it to that of the nearest noble gas, here's how chlorine starts, and it needs 1 more valence electron to get to that full octet. Remember, octa means 8. And so it'll gain that 1 valence electron, giving it a negative charge, and it will be exactly like that of its next door neighbor, argon, which has the orbital diagram as shown. And the electron dot structure is also very, very similar between chlorine and argon. They both have 8 valence electrons once chlorine has gained that 1 electron. The only difference is chlorine has that negative charge. So the big difference between like an ion and that of a noble gas is that charge. So you want to make sure you always write it. Oxygen is another example. However, its electron configuration, if you wanted to see that as well, is 1s2, 2s2, 2p, 1, 2, 3, 4. And so the number of valence electrons would be a total of 6, and that is shown here in our electron dot structure. So it sounds a lot easier to gain 2 electrons than to lose all 6 that we already have. And so that's exactly what oxygen does to create this electron dot structure, or if you wanted to see the electron configuration, it'd be 1s2, 2s2, 2p6, and the ones underlined are your valence electrons. And those look exactly like that of neon, with the difference that it has a 2- charge. And if you wanted to see that electron dot structure, it's going to look exactly the same after that oxygen has gained those electrons. So here are a couple of common anions, but you can always use your periodic table to figure them out. So these will not be given to you on a test. However, you know that if it is a -1 charge, that means that it is 1 box away from a noble gas. If it has a -2 charge, that means it is 2 boxes away from your noble gas. And if, again, you have those -3s, you're going to be 3 boxes away from the closest noble gas. So you can always figure out exactly the charge of all of your anions. So let's take a look at your sulfide ion. So remember, sulfide is telling you that IED is telling you that it will be an anion, so it should be gaining electrons. Okay, so let's take a look by checking out our periodic table. All right, so sulfur is right here, number 16. And so it can either gain 2 electrons, which we know it's going to do because it has that IDE label. So let's try and have that sulfide be created by adding those 2 electrons. Okay, so you guys should have your periodic table out in front of you, but I had to switch back so that you can see me write our electron configuration. So we should go from the 1s2, 2s2, 2p, 2p6, 3s2, 3p4, and once it gains those 2 electrons, it's going to create the electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p6. So the guys in our energy level of 3 are our valence electrons, except that this one is going to have a charge of -2. So let's check back with our periodic table to figure out which one it looks like. So if we were going to count over 2 boxes, because we did gain 2 electrons, 1, 2 would make us look just like argon. So let's see if our electron configurations match to that of argon. So I've already written out our electron configuration for that of argon, and they are exactly the same. They have the exact same electron configurations, and they are able to look very similar with their valence electrons. However, they are going to have the same electron configuration, but not the same charge. Notice how the sulfur has a -2 charge because it gained 2 electrons, whereas argon does not have any charge whatsoever. All right, so as always at the end, you have your great key concepts that you should know, your wonderful vocab words. I've got a couple new ones here this week, and I will see you tomorrow.